Hello everyone, welcome to our weekly progress video 2. In this video, me and my partners will talk about our progress in the last week. Firstly, we worked on placing protectors of the same grid. The functionality is through the button P. Whenever the user presses the button P, user can then place protectors on the grid using mouse click. When the user again presses P button, the placing functionality is disabled. We are planning to implement drag and drop functionality in coming week after implementing our shortest path algorithm. So I will give you a demonstration now. I have pressed the button P now, and now when I press my mouse button, the protectors can be placed. For now, we have just used plant zombie, and when we over the next week we incorporate all the protectors here, and so I can place protectors at random at the user defined locations uh, using my mouse. Next, we also worked on placing the obstacles randomly on the grid. These are the obstacles that the user will get as game starts as part of the terrain. There would also be specific number of allotted obstacles that the user can place strategically to protect the plant from invading animals. So the obstacles that you can see on the screen for now are the ones that were placed randomly. For now, over the next week, we will also implement the functionality for placing the allotted number of obstacles and give that to the user so that it can place it just like the protectors. And now Ammar will go over the shortest path algorithm grid that we are working on side by side or simultaneously.
So we will be transforming our grid in a 2 by 2 dimensional grid. So basically, in order to represent our tiles or the background of the plant in the Mckinsey game, so we will be representing it in a form of two-dimensional adjacency matrix. So whenever the attacker is placed, which is or attacker is randomly spawned at either tiles of the corner of the map. So in order to reach the plant, we have to use the algorithm like that extra or A star. I have basically implemented that extra for the attacker to get the shortest path towards the plant. So basically, I have implemented that extra, which is just the extra that will keep the path from the attacker to the plant. While I have not added the functionality for if the attacker encounters a protector or any type of obstacle in the map. So I have implemented the director. We first started by including the relevant headers and defining the tuple class as well. The tuple class is a class that has attributes a row and column, and also it has a constructor that initializes row and column. Basically, we also have overloaded the insertion extractor. Constructor is also defined to initialize the row and column, and the OSTream insertion extractor is overloaded to allow the printing of tuple objects to the console. Next, we define that extra function which takes in a 2D adjacency matrix graph, a starting node, start, and a destination node, dest, and returns a vector vectors or tuples containing the row and column indices of each step on the shortest path from start to destination. Basically, I have implemented the extra over here. So inside the extra function, we initialize a heap or a priority queue PQ to store nodes in increasing order of the distance from the start node. We also initialize two vectors, dist and parent. The dist vector stores the shortest distance from the start node to each node in the graph, and the parent vector stores the parent node of each node in the graph in the shortest path. We push the starting node into the heap with a distance of 0 initially. We continue to loop while there are nodes remaining in the min heap. Inside the loop, we pop the node with the smallest distance from the start node. And if this node is the destination node, we construct and return the shortest path from start to dest by tracing back through the parent array. If the current node is not in the destination node, we loop through all its neighbors. If a node is not teachable, there is For example, there is no edge between the current node and the neighbor, we skip it. Otherwise, we calculate the cost of getting to the neighbor node from the current node. And if the cost is smaller than the current shortest distance to the neighbor node, we update the dist and parent vector and push the neighbor node onto the heap. So basically, as we all aware, for all the moves, the weight to make the move will be one, since it can also only move in the directions, meaning like the four directions only, immediately adjacent to it. So as all the directions will have a distance of 1, so all the edges will have a distance of weighted edges will be of 1. And this is a sample test case I ran to find out the output.
So this time around we have done a bit of cleaning up of the code and implementing object oriented approaches. So we have so the buttons that we had in a start state, we have replaced them with button objects from a button class that we implemented, and this class is responsible for sh- displaying a button and changing its appearance based on whether the mouse pointer has been hovered over the button or not. So this provides an easy way to repeat the same code for our other states when we want to add buttons on in our play state and game over state as well. We have also implemented the generation of the plant towards the middle 3 by 3 portion of the screen. So this is how the implementation for randomly generating the plant in the middle 3 by 3 portion of the screen works. So as you can see, if I launch my game, it generates the plant towards the middle of the screen. But if I launch it again, it should change its position. See, it changes its position, but it stays in the middle 3 by 3 portion of the screen. This is done so that animals coming from the corners do not get an easy access to the plant if the plant is at an edge, and so that there is a diverse range of obstacles around the plant as well. We have also arranged our assets into sprite sheets so that we can easily access them in the game, and so that we do not have to create many texture pointers for each object. And we have also added some other animals as well, because the original assets seemed a bit lacking of variety. These are our enemies, so these will come to eat our plants, and these are our protectors, and these are obstacles.